Continuing on with linear inequalities in two variables, we're going to be talking about inequalities that contain and or. Now, just as a review, I want you to remember back whenever we were talking about intersections and unions, I need you to remember this and also this. This means A union B. I guess I need something better to point with here. This means A union B, and it contains both of the sets A and B. And then A intersection B means it contains everything that's in both A and B. So whatever you have in common between A and B, that's what's in their intersection. But if you have the union, it just means put everything that's in A with everything that's in B. Those definitions are going to be really important for what we're going to be doing in this part of the section. So what exactly does it mean? If you have an intersection, it means and. Now remember, an intersection is this symbol. Oh, can't see that color, can we? Let's try this one. This is an intersection, like this. And the union is this symbol. Okay? Looking at an example, to find the solution sets in the following problems, we will solve each linear inequality individually and then form the union or the intersection of the individual solutions as appropriate. So what we want to do here is solve this just like we did in part 1 of this video. We want to solve it for y. So I'm not really sure I'm going to have a whole lot of room. Let's see what we can do here. So we're going to add 3x to both sides. We'll end up with negative 6y is greater than 3x minus 12. Then divide everything by 6, or negative 6. So y is less than, since we divided by a negative, we have to flip the inequality symbol, a negative 1/2 x, and then negative 12 divided by negative 6 would be a positive 2. So if we wanted to graph this line, we'd go up to 2, put a point, then we'd rise negative 1 and run 2. Rise negative 1 and run 2. Now we need to draw a dashed line because this one does not have the equal to symbol under it. So here is our dashed line that represents this inequality. Now what area are we supposed to shade for this one? It says y is less than all of this, so we need to shade below that. So it would pretty much be all of this area down here. Okay, so let's look at the next part. The next part says x is less than or equal to y. Well, to graph this, I want the y to be written first. So that's also the same as y is greater than or equal to x, right? This one will be a solid line because of the little equal to symbol, and it will be a 45-degree angle right through the origin. So the red line will represent that one for us. It says y is greater than or equal to that. So for this one, we want to shade above that red line. That would be everything this direction. Everything above that red line. Okay, so then we have to go back to the original problem. Look at the word joining these two inequalities. It says or, so you're really and truly looking for the union of those two sets. Remember, union means you want to include everything that's in both sets. So the actual solution set to this inequality would be everything that was shaded either color. So it would be all of this. So pretty much everything except this little triangle right here. Now we do include this line, this, see it's dashed. We do include that because those points are in the solution set that goes along with this red line. However, we would not include these points because these points are not in either of those sets. It's getting a little deep, isn't it? Okay, let's try another one. we have 2x plus y is greater than or equal to 6. So let's solve that for y by subtracting 2x on both sides. Y is greater than or equal to negative 2x plus 6. So we would go to 6, make that our y-intercept, rise negative 2, run 1. We would continue doing that. Now this is going to be a solid line. Let's go ahead and get that graphed. So here's our line, and it says that y is greater than that. Now I don't want to shade anything just yet. I'll shade them at the very end this time. But if I wanted to shade everything greater than this line, it would be this direction right here. So let's just keep that in mind as we graph the second part. The second part says y is less than 3. Well, that just means we go to the line y equals 3 and we shade everything below it. So let's get that line drawn. So this black line represents the line y equals 3. It's dashed because there's no equal to sign here. Y is less than 3 represents everything in this area, everything below that line. Now we go back to the original problem and we look at the word joining the two inequalities. That word is and. Since it's an and, we want to create an intersection. That means we only want what's in common between those two inequalities. So remember earlier we said we would shade above the red line and we would shade below the black line. So the only thing that they have in common is this area right here. So that will be the intersection. Only this little bit right here. So let's go over that again. Y is greater than this means we shade above this line, so everything this direction. Y is less than 3, so we shade everything this direction. And since this is an intersection, we only want where those two sections meet or where they cross or overlap. So that would be this area right here. Unions and intersections of regions of the plane can also arise when solving inequalities involving absolute values. Let's go ahead and look down at the bottom of the page. Now if you want, you can pause the video and go ahead and read all of these words at the top. This is kind of how I think about it. An intersection, remember, is this symbol. It's represented by the word and you can also have this. You have the absolute value of something is less than something else. Okay, so what I really want you to notice is that the absolute value is alone and on the left side, and that this is a less than symbol. Then the union looks like this, or you can use the word or, and it means the absolute value of something is greater than something else. And in this, I want you to also notice that the absolute value is by itself on the left, and you have a greater than symbol. Graph the solution set in all the real numbers squared that satisfies the joint conditions. Absolute value of x plus 2 is greater than 3. And absolute value of y plus 1 is greater than or equal to 3. Okay, so what we should do is focus on these little pieces. We should focus on this problem, and then we'll focus on this problem. There are several things going on in this problem, and we need to make sure that you understand all the little pieces. So if we wanted to graph just this inequality, remember the rules for absolute values and inequalities. If you have x plus 2 is greater than 3, you remove the inequality, you remove the absolute value, write it just like it is. Since this is a greater than, this becomes or, and you also have x plus 2, you flip the inequality over and you make the right side negative. So this is how you would set it up. If this is greater than, this is an or. If this had been a less than, then you would make this an and. Okay, solve this one. We would subtract 2 from each side, so you would have x is greater than 1, or subtract 2 from both sides, x is less than negative 5. So what we need to do is graph two dashed lines, one at x equals 1, one at x equals negative 5. So here are our two lines, x equals 5 and x equals 1. Now they're dashed because there's no equal to sign, and they're vertical because it's an x equals equation. We want to graph where x is greater than 1. So that's going to be here. Everything greater than 1. Then it says x is less than negative 5. So that would be everything this way. Okay, so we have just graphed this inequality. So let's move on to this one. We write our inequality just as it is. Y plus 1 is greater than or equal to 3. This is still greater than, so we still use an or. Y plus 1, we flip this over and make the right side negative. Subtract 1 from both sides, so y is greater than or equal to 2. Subtract 1 here, so y is less than or equal to negative 4. So y is greater than or equal to 2, or y is less than or equal to negative 4. We need to go to where y equals 2, where y equals negative 4, and we're going to draw some solid horizontal lines. There we go. We have our solid horizontal lines at y equals 2 and y equals negative 4. Now this says y is greater than or equal to 2. That means we want to shade everything above this line. This one says y is less than or equal to negative 4. So that would be everything below this line. Okay, now this is where we really have to think. In the original problem, it says an and between those two inequalities. That means we want to take this graph, the yellow one, and the green one, and overlap them and see what they have in common. Okay, so what I want to do is transfer all of the lines onto this new bigger graph. Let's see if I can do that while we're still here. So this one is at negative 5. The next one is at 1. Okay, that won't actually get on that line, so we'll just have to leave it as close as possible. And then we want this one, which is at 2. Again, we're just going to get as close as possible. And negative 4. Oh, that one worked out nicely. Now, each of the dashed lines we shaded on the outside, and each of the solid lines we shaded above and below. So the total solution set is the and, that's the intersection of those two shaded regions, or 4 shaded regions. So you can see that what they would have in common would be this small area, also here, and here. So those 4 areas represent the solution set to this original inequality.